Okay, what you see in front of you is a statistics software screen, and I want to do the diamond data set. I want to do a simple linear regression example using the diamond. So the first thing I needed to go and do is get the data set. So I guess I'm going to come here. I have downloaded the Excel version. There's two versions that I posted in Canvas. One's the Excel version, one is the statistics. I'm going to show you how to import an Excel file. It's very simple. You go and find it. So let's see, it's on my downloads, so I should be able to go up here. Let's see, this PC should be able to go to downloads, and there it is, a diamond data set. And when I do that, it's going to ask me, what do you want to do with these variables? And I'm going to hit OK, and sure enough, there they are. Now the only two we're going to use for this example is price and carat, because I want to do a simple linear regression. So to do that, we're going to come in here to linear models. We're going to go to linear regression. And when I go to this menu, it's going to ask me, what variables do I want to work with? Well, we're going to try to predict the price based on the size. Price by carat, and I'm going to say OK, and I'm going to get my linear regression. I'll make this a little bit bigger. Let's do this, and I think you'll have a better look at it here. There we go. Very nice. And so you can see that we have our variable and our y-intercepts, our estimate of the y-intercept and our estimate of the slope. And so I would say my prediction equation is y hat is equal to negative 2298.36 plus 11598.9 times x, where x is the carat size, y is the price. Okay? Now, to interpret my variables, that's my y-intercept, my estimate of the y-intercept by beta naught hat. And so I would say, to interpret that, I would say when x is equal to 0, this is what we expect y to be. When the carat size is 0, I estimate the price to be negative $2,298.36. And I hope you're thinking, what? It doesn't make any sense. Sure it doesn't. Of course it doesn't. We can't have a, can you have a diamond that's got a 0 carat size? Does that even make sense? It's more of a philosophical question, right? Can you have a diamond if it's got no carat size? No, they don't exist. If I come over to my data, and if you look at the carat sizes, is the data sorted by carat size? It looks like it is. Yeah, look at that. My smallest, let's see what the biggest, oh no, it's not. Well, I can do it this way. Let's go and look at some descriptive statistics, and I'll choose carat size. And it's going to tell me the minimum is 0.18 carats, the biggest is 1.1. So even if you could rationalize, and I don't think you can in this case, but even if you could rationalize a value of x equals 0 makes sense, I didn't sample over a range that included that. And so for a couple of reasons in this case, I'm going to say that the y-intercept interpretation is not practical. The slope interpretation, right here, that's always a practical interpretation when you're fitting a straight line. And we're going to say for every 1 unit increase in x, this is what we expect to happen to y. Well, for every 1 carat increase in the size of the diamond, we estimate the price to increase, because it's a positive number, by $11,598.90. These are apparently some very expensive diamonds, right? For every 1 carat increase, the price jumps by almost $11,600. Those would be the beta interpretations for this particular model. The assumptions that we would state, okay, I'm kind of going through the steps. Step 1, we'd hypothesize a straight line model. I didn't really mention that because that's always the same for a straight line. The beta interpretations, fitting the model and getting the beta interpretations, that's step 2. Step 3 is the assumptions. There are 4 regression assumptions. The mean of the epsilons is 0. The epsilons are normally distributed. The variance of the epsilons is sigma squared, and it's constant for all settings of the x's, and the epsilons are independent of one another. I'm just going to restate the 4 regression assumptions that we've seen before, and now I would want you to be able to interpret this number over here for me. The standard deviation. We expect most of the y values to fall within 2 standard deviations of their predicted values. Okay, now make that work for this problem. I expect most of the diamond prices to fall within 2 standard deviations. What is that? $2,235.12, if I can do some math in my head. $2,235.12. Yeah, I nailed that. We expect most of the prices to fall within $2,235.12 of their least squares prediction equations. So when I talk about, what's that, 2235. So if you look at that, 2235 above, 2235 below, all of a sudden you're talking about 4,500 wide. That's pretty wide. I don't know that this is going to be all that useful in terms of pinpointing the price of a diamond. But that's the beta interpretations. That's the, I guess this one is specifically, this is the beta interpretations up here. This is the standard deviation interpretation, is what I should have said. And we do that in step 3. Step 4 is testing the model. Is the caret size a statistically useful predictor of price? What kind of test would you do here? I would test beta 1 is equal to 0, meaning the slope of the line is 0, which in words says the caret size is not a useful linear predictor of price. What kind of test? Would it be a greater than, a less than, or a not equal to? How do you know? Well, what do you expect is going to happen? As the size gets big, what should happen to the price of the diamond? It should go up. Yeah, it should go up. It should get a lot higher. And so as the caret size goes up, we expect the price to go up. We're going to test beta 1 is greater than 0. We're going to do an upper tail test. And so when I come over here and get the test statistic, that's fine. When I get the p-value, now in this case I have a value of 0, so it's pretty easy to work with. But what should I do to this p-value? Remember, that's a two-tailed p-value, so typically I'm going to divide it in half, but of course with it being already a 0.0000, splitting that in half gives you the same number. And I think I've mentioned, at least I've mentioned to a lot of students that have asked me individually, this p-value isn't really 0.00. It isn't 0, let's say it that way. It's 0.00000002. And when you round it to 4 decimal places, that's the way you see it on a printout. And so we would really want to take this and divide it in half, but it's a p-value. When p is low, we know that we can reject the null hypothesis. So split this in half, and it's even lower, but this is a reject H0 p-value. At alpha equal 0.01, I'll choose a 0.01. We reject H0. There's sufficient evidence to indicate that, and the part after that is always what the alternative says. There's sufficient evidence to indicate that beta 1 is greater than 0. Now, what does that mean in the words of this problem? There's sufficient evidence to indicate that the caret size is a statistically useful positive linear predictor of price. There's a positive linear relationship between caret size and price. You could say it either way. They are positively linearly related. That's how we do the test on the model. Now we'll come down here and take the r-squared value, and we'll talk about our r-squared interpretation. Remember r-squared we had in the conversation? Talked about how it's explaining variation in the y values. We can explain 89.25% of the variation in the sample prices around their mean by using caret size in a linear model. Okay? What we're saying is by using caret size, we can explain 89% of the variation that we see in the y's. It's a pretty big improvement right there. Now, we also said from a practical point of view, we're not getting real accurate. Right? We can predict to within most of the prices fall within what, 22, 35, 12? Isn't that what we said? Yeah, it's a pretty wide interval. But from a statistical perspective, it is significant. Using caret size is better than not using caret size. What the standard deviation is trying to tell us is there's still room for improvement. So step 4 is where we do that. We do the test hypothesis. We interpret a p-value. We interpret an r-squared value. And now we want to use it for estimation and prediction. So let me go ahead and show you how to do this. Let's say I want to purchase a 3/4 carat ring. I shouldn't say ring. I should say diamond because the rings aren't included here. I want to purchase a 3/4 carat diamond. There's a couple different ways of doing it. One way is to go back out to the data and find a diamond that's 3/4 carat. Let's see if I can find one here. There's one. And see, it's case number 107. So one way of doing it, and that's not what I want to do, we get to the linear regression, okay, and then we dig a little deeper. So I'm going to go here, and we're going to come down here to prediction. Okay, so we're going to go into prediction. I'll click on that. One way of doing it is there's this method called the values method. Now I can just put in the value 0.75 in here. And the variables will be listed over here on the left, and there's only one in this case. It's just a caret size because I didn't use any of the other variables. And so I put in the value that I want to work with. So 0.75 caret, that would be the way to go. Another way is to use what's called the case number method. And you can see method is cut short here. But the case number method, here I come down here and I'm going to say use case 107. And now what it's going to do is it's going to go to case 107 in a data set, and it's going to say, I'm going to choose the value of x for that case, which of course I just showed you was the value of 0.75. So I'll hit OK here. And you can see it used case number 107, has a caret size of 0.75. So let me get out of here, and I'll show it to you the other way as well. I'm going to come here. I'll go back in. It remembers where I was. OK. And now when I dig a little deeper, I'll go to prediction, except this time I'm going to get the 107 out of here. I'm going to put in a value of 0.75 right here and hit OK, and it's going to give me the same printout. The numbers are exactly the same on this printout as when I use the case number method. So you can get there a couple different ways. If you have a value in your data set you want to use, that's fine. If you decide that you have another value of x that you're interested in, by all means use it. A couple different ways of getting there. Main thing now, however, is I want you to be able to tell me what these two numbers here represent. The upper and lower predicted bounds. I also want you to be able to tell me what these numbers represent. And so you should be able to make both interpretations for me. Let's do this one over here first. Okay, the predicted values. That's typically the one that students have better success with. This is just a confidence interval, so we're going to interpret it as a confidence interval. How are we going to do that? We are 95% confident that the price of a single, because I'm over here, the price of a single diamond that is 0.75 carats big. Or you could say the price of a 0.75 carat diamond. That works. We're 95% confident that the price of a single 0.75 carat diamond falls between $4,197.50 and $8,604.10. And you might look at it and say, wow, that's pretty wide. But that's our prediction interval. What are these guys over here? Well, how's the wording change? We're still 95% confident that. We're still going to say falls between. Now we're going to use these two numbers here. It's the piece in the middle, the parameter. The fitted isn't for a single value of y. Remember what that's for? E of y, right? That's the average price of all 0.75 carat diamonds. Doesn't matter which column I'm in, the predicted over here or the fitted on this side, I still have to mention the carat size. Because as I change the carat size, see what happens. Let's go, let's go to here. See if it'll let me do this. It's not going to let me do that. As I change the carat size, the numbers are going to change. Let me go in here and choose a 1 carat diamond ring. Statistics makes me go out before I want to do it again. Let's do a 1 carat and see what happens. The prices went up, didn't they? Of course they did. We went from a 3/4 carat to a 1 carat diamond. So over here, how would I state this? I am 95% confident that the average price of all 1 carat diamonds falls between $9,091.60 and $9,509.40. I'm 95% confident that the price of a single 1 carat diamond falls between $7,091.50 and $11,510. The price of a single one that has this value of x, the average price of all that have this value of x. That's how we make our interpretations for the prediction interval and the confidence interval. So hopefully that makes sense to you. So let me go back to the analysis of variance table. So you should be able to interpret that guy. You should be able to do that one. You should also be able to tell me whether you should be doing that. Is that a practical interpretation? The test hypothesis gives you those two numbers to look at. Should be able to interpret a standard deviation and an R-squared value. So lots of different pieces. Hopefully they fall into place and it makes sense. We're going to look at a lot of similar ideas when we get to multiple regression. It's just this part of the printout right here is going to get a little bit more complicated, a little bit more, it's going to grow. You're going to get more rows in the printout because we're going to add different relationships. But that's for another time, another lecture, another video. For now, hopefully that simple linear regression looks pretty good to you. Probably the best data set to practice on, however, is yours. Because I'm going to ask you to work with yours in the simple linear regression project coming up soon. So if you want, get playing around with that. Create the linear regression printout, then go ahead and do a prediction interval for a value of x that you choose and see how you do. Be a good thing to look at. All right, that's the example. I'm looking at the time right now. It's a little over 15 minutes. Probably took me an hour and a half to talk about all the different pieces of the simple linear regression, and takes us about 15 minutes. And I still feel like I was wordy here. Sorry about that. See if you can't streamline it even further. If you have any questions, you know how to get hold of me. Good luck.